Alright, week 30, part 1. So we're talking about sequences and series in this unit. So we'll start out with sequences and summation notation. I think we'll get to that in the next notes. So first of all, this is kind of a definition of a sequence. And students tend to think of it as, well, it's just, if it's a list, it's a sequence. If they're added, it's a series, which is fine for now. But any ordered list of numbers can be viewed as a function whose input values are 1, 2, 3, meaning very ordered, and whose output values are the numbers in the list. So when we have this 2, 6, 8, 10, this is the first and second and third and fourth and fifth term, we say. And we use this notation here. This is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. So we use that notation to describe the terms in the sequence. Okay, so when we're looking at this and we're trying to recognize the pattern, we see 2, 4, 6, 8, and we recognize, hey, I'm adding 2 every time, and so we could sort of figure out that the next term is going to be 12, and then 14, and then 16, and so on. If we were using words to describe that, we might say something like this. Well, we're adding 2 every term, and we're starting with 2. Right? If you were starting with 3, it would be 3, 5, 7, 9, be the odd numbers. So that starting with 2 is kind of important information. But what we will be focusing on is, first of all, recognizing a pattern, writing the next couple terms, and then writing what we call the nth term. So what does that mean? The first term is this, second term is this, third term is this, fourth term is this, fifth term is this. So if I ask you, well, what's the 100th term? Sure, you could sit there and add 2 a whole bunch of times, right, 95 times. Or hopefully we could sort of figure out an equation that would actually tell us what that is in terms of n, and n is the term number. So I'm going to write this, and you should too. So for this term, a sub 1, we would say n equals 1. And here n equals 2, and n equals 3, and n equals 4, etc. n is the term number. Okay, so if we have something like this sequence of numbers, and we're asked what is the nth term, so we're looking for an expression involving n that we could just plug in and get, hey, that's the value of the 100th term or whatever. So do we see how when n equals 1, the value of the term is 2, and when n equals 2, the value of the term is 4, and when n equals 3, the value of the term is 6, etc. So hopefully you're seeing this pattern that if we take n and multiply it by 2, we get the value of the term. So fifth term is 10, sixth term is 12, seventh term is 14, eighth term is 16. So instead of having to add 2 a whole bunch of times, if you were asked what is the value of the 100th term, and you would write that like this. So the 100th, a sub 100, the 100th term is going to be 200. And we don't have to add all those values out to there. We know, based on our reasoning, that the nth term will have a value of 2n. Okay. So I like these. They're pretty fun. We're recognizing patterns. Alright, so here we go with the sequence. We have 1/2, 2/3, 3/4, 4/5. So you're probably recognizing that we add 1 to the top and we add 1 to the bottom. So the next term would probably be 5/6, and the term after that 6/7, and the term after that 7/8. And if we were describing this in words, we might say, what do I say here? Add 1 every term to both numerator and denominator, starting with 1/2. Alright, so add 1 every term to both numerator and denominator, starting with 1/2. That is how I would describe this in words. So the challenge is then, so if someone said, well, what's the 100th term? Alright, hopefully we could figure this out. So we're looking for a formula for the a sub nth, so for the nth term somewhere out here. So we have this, let's see, this is the fifth term, so this would be for n equals 5, which we call a sub 5, and for a sub 6, which we call, well, for the, excuse me, for the sixth term, which we call a sub 6. So what's the pattern? Let's see. All right. First term, we have a 1 up here and a 2 down here. Second term, we have a 2 up here and a 3 down here. Third term, we have a 3 up here and a 4 down here. Fourth term, we have a 4 up here and a 5 down here. So for the nth term, we would have an n up here and an n plus 1 down here. So do you see how this works? Where for the first term, right, if we put a 1 here and 1 here, we got 1 over 2. Aha! And for the second term, if we put a 2 up here and a 2 down here, we get 2 over 3. Aha! Over here for the fifth term, if we put a 5 up here and a 5 down here, we get 5 over 6. Voila! So this is our answer. I wrote it in the wrong spot, shame on me. For a sub n, it would be n over n plus 1. So the 100th term, yes, would be 100 over 101. Alright, next up. Oh, so I wrote over some of my writing. Dang it. So we have this sequence of numbers, 0, 3, 8, 15, 24. Your notes say 25 right here. That should be a 24. Would you cross it out? Oops. And so we're trying to recognize the pattern. So at first I saw, well, let's see, we add 3, and then we add 5, and then we add 7, and then we add 9. And so I assumed, correctly so, that, oh, we would be adding 11. And that is correct. There's another way of looking at it, though. So here for the first term, so when n equals 1, we have 1 squared minus 1. Here we have 2 squared minus 1, 3 squared minus 1, 4 squared minus 1, 5 squared minus 1. So this is just a different way of looking at it. But if we're trying to come up with this, which we call an explicit formula, so a sub n equals what? We are looking for this. What? This is called an explicit formula. Explicit because what an explicit formula, not like it's bad words, but it means that we can figure out the value of some term, and so I use the 100th as just the example. We can figure out the value of the 100th term by just plugging in 100. We don't have to figure out all previous 99 terms. That's what we're looking for here. So this is our answer for the first term, 1 squared minus 1, second term, 2 squared minus 1. So for the nth term, it would be n squared minus 1. Using this information, the plus 3 and the plus 5 and the plus 7 and the plus 9 and the plus 11, to come up with an explicit formula is more challenging. Let's look at, so I was describing this in words, and I said, well, you add 2 more than we added previously, starting with adding 3 to 0. That gets a little complicated when we're taking this information and trying to turn it into that. But luckily, we saw that it was a perfect square, or 1 less than a perfect square, and we were able to come up with this explicit formula. So we're starting with these patterns, so we're recognizing patterns, and we are coming up with both. So we'll be looking for explicit and recursive formulas. So on the next slide, let's see, where do we go? Oh yeah, right. Alright, so what on earth is a recursively defined sequence? So recursive, this is, well, ask your English teacher, but the word recursive comes from something that's sort of repeating or happens again and again, that type of thing. So when it's a recursively defined sequence, we know the value of a term based on the previous term. So classic example, Fibonacci. We'll study this in more detail. So the Fibonacci sequence of numbers starts with 1 and 1, and then each successive term is the sum of the 2 previous terms. So each successive term is the sum of the two previous terms. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21, etc. And this pops up all over in nature. It's got tons of cool applications, and we will look at these. But it's a good example of a recursively defined sequence. So again, recursive, what did I say? Who knows? Recursive, I think, yeah, we need to do this. So a term is defined in terms of, let's say as a function of. It'd be weird to use the word term to mean two different things in the same sentence. Term is defined as a function of the previous term. And kind of doing this out of order, but if we were to similarly define an explicit formula, we would say that a term is defined as a function of and what do you think? As a function of the term number. The term number. So when we say what's the 100th term, if what we know is a recursive formula, it means we have to know the 99th term. I'm going to write this. Hey. So for a recursive formula, if we want to know the 100th term, we have to know the previous one, which is the 99th term. And in order to know the 99th term, we have to know the previous one, which is the 98th term. And in order to know the 98th term, we have to know the previous one, which is the 97th term, etc. So you see how there could be a lot of work. However, if we have an explicit formula and we want to know the 100th term, we plug in n equals 100 and kaboom, there it is. All right, so Fibonacci sequence or series looks like this. And so if we were coming up with an recursive formula, not an explicit, with a recursive formula, recursive, it would look like this. And I'm going to say this very specifically because frequently students freak out when they have to actually say this in words. So what we say is that a sub n equals a sub n minus 1 plus a sub n minus 2. I might even write that. A sub n equals, because if you do this now, you'll be saying it correctly forever, and you'll have a happy life. A sub n equals a sub n minus 1 plus a sub n minus 2. How do I spell 2? 2. Okay. So let's see if we can, so we'll return to Fibonacci, but let's take a look at these, see if we can come up with a recursive formula. So we're looking for a recursive. Recursive. There we go. I'm going to blame it on the stylus. So here's our first term, here's our second term, here's our third term, here's our fourth term, here's our fifth term. And we've already done this. We've come up with the explicit formula. But if we have a term, what is it in relation to the previous term? So do you see how 10 is 2 more than the previous term? So what we would say is that a sub n is equal to a sub n minus 1, meaning the previous term, plus 2. So this, we can, if we assign words to them, this is any term, and this is the previous term. Meaning if this is 10, this is 9. If this is 5, this is 4. If this is 100, this is 99. So this is a recursive formula for this sequence of numbers. Here we have a different sequence of numbers, and it looks like something is happening each time. So in order to get from here to here, we could multiply by -1/2. And in order to get here, we could multiply maybe I'll do that. Multiply by -1/2, and multiply by -1/2, and so on. So if you take any term, in order to get this, it was this one times -1/2. So we could say any term is the previous term times -1/2. So any term, previous term. Alright, so those are some examples of recursive formulas. And then let's talk about this example. So it says find the first 5 terms. Alright, and what we're given is this. So what type of this is definitely a formula, right? What type of formula is this? Well, this is recursive, and here's how we would say this in words. A sub n equals 2 times, parentheses, a minus 1 minus 2, n parenthesis. And so in words, what this says is that any term, well, I'm not going to write all those words. I'll just say it. Any term, to get any term, you take the previous term, subtract 2 from it, and then multiply by 2. We'll pause there. So to get this term, we took the previous term and we're plugging it in here. So we took the value of the previous term, which was 3. All right, so here are our numbers. We took the previous term, subtracted 2, multiplied by 2, and got 2. To get the value of the third term, we took the value of the second term and plugged it in here. 2 minus 2 is 0, multiplied by 2 gives us 0. To get the value of the fourth term, we took the third term, plugged it in. 0 minus 2 times 2 is a -4. To get the value of the fifth term, which is this guy, we took the value of the fourth term, plugged it in. Let's see, -6, 2 times -6 is -12. Okay, so this is using an explicit formula to come up with the first. So this would be first, second, third, etc., and fourth and fifth term in this sequence. Okay, and let's see. Oh, this additional, sorry, this was cut off, but I'm sure you saw it in your notes. A sub 1 equals 3, meaning the first term is 3. Alright, last example. Find the nth term of the sequence. Let's see. We have 1, 4, 7, 10. So if we look at the pattern, it looks like we're adding 3 every time. So we could say, well, probably goes 13, and then we add 3, we get 16, etc., etc., etc. So we're looking for this relationship between n, the term number, and the value of the term. So when n equals 1, the value of the term is 1. When n equals 2, value of the term is 4. When n equals 3, value of the term is 7, etc. So an explicit formula, find the nth term. This is what we're looking for. Find the nth term of the sequence. So this is asking for an explicit formula, right? If we were looking for a recursive, so to digress, recursive formula, we could say a sub n, any term is the previous term, that's an n minus 1, is the previous term plus 3. Alright, and that one was a little easier for this. But to find an explicit formula where we can just plug in n to find the 100th term, so here's the way to think about it. Do you see how we start with this? By the time we get to here, we've added 3 once. And then we've added 3 twice, and then we've added 3 times. So there's this 3 that's getting multiplied by something. And what it is 1 less than the term number. So for this, we added 3 times. Here we added 3 twice. Here we added 3 once. So the term number, that is 1 less than the term number. And if we multiply 3 by it, so let's see, okay? Let's pretend that I don't know, and I'm kind of writing this down, and I'm thinking. So when I plug in 1 for n, I get 0 times 3 and 0, except I need 1. So I think I'm close, but let's see. If I plug in 2, so for n equals 2, I plug in a 2 here, and I'd get 1 times 3 is 3. Ooh, but I just need one more. And then if I plugged in n equals 3, 3 minus 1 is 2 times 3, and I just need one more. So what if I did this? And I think that's going to work. So if we plug in 1, we end up with 1. Oh, 0 plus 1, 1. If we plug in 2, right, we end up with 4. If we plug in 3, we end up with 7. All right, so a sub n would be this. So this right here, that's the value of the nth term. Nth term value. If we wanted the value of the 100th term, we could simply plug in 100 and we'd get 3 times 99 plus 1. Okay, thanks for listening.